Um, it's taking the default timings here, which I want to clear. Yeah. Okay. Sorry about that. So that's the whole agenda of this session. We want to introduce cloud computing for absolute beginners. My name is Akshay Kumar Pallerla. I'm a data engineer at NTT DATA, Costa Rica. I'm a professional data engineer certified by Google Cloud. That's pretty much it. GTG Pura Vida, you can sign up for future events like this if you like it. So without any further ado, let's look at our agenda today. It kind of became a spoiler already. So I think I was sleeping while I was preparing this slide, but then I hope my audience have a different agenda. Let's not sleep for an hour, especially for people in India. So I believe this session will be really useful, and let's look at the actual agenda now. So this is an introduction, right? So whenever we are introducing something, we cannot get away with definitions. So yeah, the first thing we'll be discussing is some definitions surrounding this cloud computing buzzword. Then we'll be discussing some of the jargon, I would say the terminologies frequently used in cloud computing world, mostly using analogies, because as I said, it's targeted at absolute beginners. I don't want to scare them with the regular tech jargon, but we'll look at an analogy, we'll translate that into a relevant technical term. So that way anyone can understand what exactly I'm referring to. Then we'll put all those terms together and probably discuss one enterprise level case study where this cloud computing is useful. And this is cloud computing is a methodology that can be deployed or serviced in various ways. Again, so the classification is in terms of deployment models and service models. Right now, don't worry if you don't grasp what it is. It's not necessary. I'll be explaining them in detail when we come there, with an analogy, and again we'll translate that into a relevant technical term. And then the routine questions and thank you, right? So let's get started. I hope you guys are able to see this disclaimer. Again, I really want to get this point across, so I'm repeating it again and again. This is for absolute beginners, and for them, I extremely oversimplified the concepts that I'm discussing here. So there are certain analogies that I've solely provided, to explain the concepts in a simplistic manner, but the actual technical complexities might vary. So don't take those analogies as the source of truth. Refer to the official documentation for the whatever cloud provider you use. Again, cloud provider is a keyword. Don't worry if you don't understand that now. Always refer to the official documentation for the exact definitions and latest information. These analogies are only to simplify the concepts and give you a perspective of how to think about cloud computing. Verbatim. So definitions, right? The session is all about cloud computing. So before discussing cloud computing, we will discuss computing first. So what exactly is computing? Computing is nothing but a goal-oriented activity which uses computers in a very simplistic manner. So with that out of our way, what is cloud computing? Do you know that? Do you know distributed computing? Do you know grid computing? Do you know cluster computing, utility computing, fog computing? Honestly, I don't have an idea into lot of those things, but don't worry. The reason I mentioned those things there is cloud computing is not something that has happened viral in 20th century. There have been various computing paradigms that have been evolving over a period of time, and which eventually gave us a unique utility model of computing called cloud computing. So I'm not gonna tell you the evolution of cloud computing here, so because the session is introduction to cloud computing, not the evolution. So don't worry about those terms, but I just wanted you to keep in mind that cloud computing is not something that has, become an overnight star. So American Computer Society defines cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of blah, 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 blah. So that's it. So that's the definition. The problem with the definitions is they're accurate. If you read them clearly and thoroughly, they're 100% representative of what they're trying to define. But the only problem is what they're trying to define is not actually perceivable to a layman. The whole effort we have put here is to ensure this particular definition, before you read, might not make, before you listen to this presentation might not make sense, but after you attend this session, should make some sort of sense for you. With that in our mind, let's move on. As I said, we'll be discussing certain terminologies used in cloud computing world. And in order to discuss those terminologies, let's develop a plan to host a website. Now, you guys will be like, Akshay, you said this is for absolute beginners. Of course, I may or may not know cloud computing. Now you're asking me to know how to host a website? Well, don't worry. Instead of hosting a website and discussing all these terms, let's host a wedding and discuss these terms, right? Who is ready to get married? Focus on these terms, and we'll see what exactly these terms mean and how we can translate them using analogies of hosting a wedding. Now, all of us, we have to think about hosting a wedding, right? So for a wedding, we need a couple and we need some guests who will attend and we need a hall. So I'm giving an analogy to discuss high availability in the next slide. So this is a wedding that we have planned. We are planning to host that wedding in Hall A. Now, when we spoke to the Hall A owners, they said, hey, most of the guests you have, most of the guests you have invited or you anticipate to visit are in and around Hall A. So we really recommend you to use this hall. But then the date on which you have actually planned to have your wedding, we are anticipating a power outage or a service disruption of Wi-Fi or water availability. So he cautioned us that. Now, we don't want our guests to travel a lot, but we don't, at the same time, we don't want to have a nightmare hosting a wedding, correct? So we had, kind of a plan B option set up. So we maintained the same setup of Hall A at Hall B as well, right? Now, in a high availability mode, we are hosting this wedding. What does that mean? So as the hall owner said, there is a service disruption at Hall A on the day of wedding. Now, all these guests who were supposed to reach Hall A were notified that, hey, Hall A is not available. The wedding is not happening there. So go to Hall B. They went there. But then they say, hey, I don't see anything here. There is no wedding happening here. Then we'll say, hang on. So the couple moves there. So they've come to witness wedding. Maybe that's the kind of service you wanted to witness. So even though the primary option has failed, you are able to witness that particular wedding because of the failover option, right? Now, I could have, animated the couples moving first to hall B, the couple moving first to hall B, and the audience moving later. But the point where the audience were not able to see what they're expected to see, I wanted to make it explicit. There is a minimal time where the service was disrupted. That is the time between, switching from the primary hall to the secondary hall, right? So in real world, in terms of, computing world, users like us, we may not be able to see those differences when they happen. But I wanted to, introduce that high availability concept and service disruption minimal. In most of the cases, the service disruption in between will be really minimal. You have to keep that, right? So the guests have been routed to hall B, but then they were not able to see the wedding happening there. And after a moment, they started seeing what they were expecting. Why is this important? You'll understand it once we discuss fault tolerance. So, same thing, we are hosting a wedding again. This time, I want to explain fault tolerance to you. So, what's the difference? In high availability, you did not see the couple replicated, right? So to explain this fault tolerance, I have cloned that couple, okay? So it's the same exact wedding, same set of people that are getting married. I cloned them and they're getting married here and here at the same time. All the proceedings are exactly the same. Now, the incoming guests, whoever are visiting the wedding, based on the capacity of each hall, based on the occupancy levels so far, I can distribute them. I can probably say, in this particular situation, hey, you two guys go to hall A, you two guys go to hall B. They are not really aware that they are witnessing it in a different environment. For them, everything is the same, right? So with this figure itself, you guys are able to see there is some difference between high availability and fault tolerance. I'll explain it completely now. So as the owner said, Hole is, it's shitty. It keeps having service disruptions. So the same thing happened here too. So what I've done, all the guests, they were already at hall A. I have moved them to hall B, and they don't see any difference at all. Again, the wedding is already happening here. It's not like high availability mode where there was slight delay between witnessing what was supposed to happen and when they see it. And even the incoming guests, I would have probably split them into two here and two here if hall A was working. But in this case, I don't have an option, but I have to ask them, or I have to route them to my failover option, right? Now, there is no service disruption here. All the incoming guests are witnessing what they have come for. Meanwhile, in this particular time, I can probably, turn on the generator or come up with a mechanism to repair it and balance the load again. When I say it, so 12 folks are here. So the simplest way I can balance the load is I can shift 6 people from here to here because they're not seeing any difference at all. I just want to do it because I don't want to overload this particular hall, right? So far, any questions? I really want to get through the difference between high availability and fault tolerance. Trust me, there are tons of people out there who are kind of in a assumption that both are almost the same. But yeah, there is a slight difference. They're almost the same, but there is a slight difference. Any questions? Okay, I'll take that as a no. We'll move on to discussing the next terminology in cloud computing. Instance. So I just zoomed into one of the halls. As I said, each hall has a limited seating capacity. The couple is getting married here. In order to explain scalability and elasticity, the subsequent and most important terminologies in cloud computing, I'm assuming every person sitting here is an instance at this instance. Okay, so there are at this instance, 4 instances are witnessing the wedding, and the seating capacity is 5. Now, let's say there is another guest who is planning to visit this wedding. Now, of course, we can't stop him, right? After all, they're guests, so we have to host them. I will allow him, right? Now, another instance has been added to witness this wedding, correct? But the problem here is my capacity of this particular hall is fulfilled. I cannot have more guests. Ethically, I really want to host all the guests. I really want to honor all the guests that who are attending the wedding. But then I am bound with the seating capacity here. This is really important here because this particular limitation is what actually drives companies and enterprises into cloud computing in most of the cases. Of course, the price differential between on-prem and cloud is a huge factor too. But at times where you really value hosting your user experience or hosting your guests very well, you don't look for money. So in those times, you don't want this limit to happen there. So I believe you guys are able to understand what do I refer to when I say an instance here. On a relevant note, we'll discuss elasticity and scalability in the next slides. Excuse me. So the difference you see here is, in the previous slide, you were able to see a bound on the seating capacity in the hall. Now, what you've done is you've made this wedding scalable. What do I mean by it? I don't see a number here. I say not applicable. What exactly does that mean? So another guest, the next guest comes to attend the wedding. I host him. Another guest comes, then another guest comes, I host them too. Another guest comes, I host them too. So I'm able to add those instances. As I said, I'm referring to these persons as instances here. Just to explain the concept of instance scalability and elasticity. Okay, of course, we'll be translating this into a relevant technical terms again when we come to it. So I'm not bound by any limit. As the demand for the wedding grows, I'm able to accommodate those requests by adding the required number of instances, right? So my wedding is scalable. This should bring you another question, right? How about, let's say this wedding is happening, or this wedding was happening in 2019. 2019 is a great year. So let's say it's my wedding only, right? So my friends, my colleagues, my managers, all my TICO friends, TICAs, everyone, they really like me and they attended my wedding. I didn't anticipate that. So, but then because my wedding was scalable, I was able to accommodate all of them. I was able to honor all of them. Now let's move that wedding to 2020, right? It screwed not just my life, everybody's life. So if the wedding happens in 2020, even though I have the same set of people and the same people, have the same respect towards me, I don't see a similar scenario in 2020. I see less number of guests, right? So that's elasticity for you. Now, again, there is no seating capacity limit, even for the lower end. So that's why I have put NA. So even though my wedding was scalable, it's elastic as well. So even if the number of people reduce, I can, manage with that. And if the number of people increase, I can accommodate them as well. Because it is elastic, I can either expand the scope of my wedding or, decrease it. And one good thing is this particular hall owner, he charges me, okay, if you need not pay to host your wedding for the whole day, or you need not own the entire wedding hall. What I'll do, I'll give it on a dynamic basis for you. So on the same day that you are getting wedded, there is another couple who wants to get wedded, right? So they also want to book the same hall. Now, the same set of couple will be there too, and those guests will also come. So you can distribute the cost of renting that particular wedding hall, right? So that way it's win-win, both for the hall A owner, for me, and even the person or the couple getting wedded the same day as me. We are sharing these resources together. I believe, things are coming together based on the definitions we have read so far, right? So this is what we call like a pay as you go model, right? Like if you have electricity at house, you don't pay lump sum at once. Based on the number of units you consume, you will be charged accordingly. So why not, use the same utility uh, principles in terms of accessing computing resources as well? That's cloud computing. So it can be highly available, fault tolerant, scalable, elastic, and we have seen what an instance means. With all this, we'll move on to the next terminology, disaster recovery. Now, again, I really want to get through one disclaimer here. Focus on the importance of disaster recovery rather than the plan A, plan B here. Focus on why it is important to have a disaster recovery plan rather than thinking about having a plan B. You'll understand why this disclaimer is needed here, because let's say the same couple, they wanted to get married, but then for some reason things didn't work out and they broke up, right? So what will happen in that case? Without a disaster recovery, what will happen is, this is how I'll end up, right? Or the person who wants to get married will end up. Now, the point I'm trying to get through here is, it's always important to have a plan B, right? So what's the plan B? I don't want to, end up single. That's out of my thought. So what's the plan B? Yes. I need not explain this. So I hope this gets through the point of importance of disaster recovery. So in a traditional model, you really have to manage this as well. But one good thing with cloud computing is the cloud provider themselves, they offer this disaster recovery for you, which is really important. Again, focus on the importance of disaster recovery here, guys. Okay. So with all the terminologies discussed so far, I believe things slowly start making some sense, if not completely, right? All those analogies are just to get through my points, but all those individual terminologies, when they put together, create this unique method of offering computing resources to users, which is called cloud computing. So let's put it all together. But before I proceed, any questions? Okay, moving on. Yeah. So we have come up with the premise of, okay, all the terminologies, we have read the definition, but mentally mapping this particular cloud computing system, how do you do it, right? So all of you guys, like you might be having a mobile phone or a laptop or a desktop, right? In fact, using one of those devices, you might probably be looking at this presentation today. So what exactly those devices have in common? So everything is actually a computer, right? They have some compute power, have some storage power, they have some networking, they have certain features setting them apart, right? So the same device that is in your hand, which has compute power, storage, networking, security, all that stuff, you just move it to a different place, right? So we have been discussing, okay, cloud, the mystery box, put it there. So using the internet, using ISP or Wi-Fi or your mobile data, all you're doing is, instead of using that compute power or storage or whatever in your hand, you're connecting through internet and connecting to that device which is sitting somewhere else. This cloud is basically a mesh of all the hardware, all the infrastructure, network, software layers that have been created to provide this computing paradigm to you. It's as simple as that. So just move the device from your hand to somewhere else in a different part of the world or in the same region. All you're doing is using that compute power or accessing that compute power over the internet. This is good, in terms of thinking mentally what exactly is a cloud. In reality, what exactly it is instead of a single device, it's a data center that you're connecting to. That's it. So a data center is nothing but, let's imagine I have a laptop, my roommate has a laptop. Everything, all the laptops, I connect them together. I use them like kind of compute powers stacked together, serving something for some users, right? So a data center it's relatively big in size, but the whole abstraction I'm doing it is basically to again get the same point of view. The compute power, storage, all those features we talked about, they are available somewhere stacked in a huge data center. You are connecting to them through internet. That's it. So let's say in a real life example, you guys would have used Google Photos and iCloud, Dropbox. So every day, the photos you take, the documents you upload, the videos you take and upload, the media files you upload, what exactly is happening? It shows a symbol like cloud. What exactly does that mean? So it doesn't matter you take a photo from mobile phone, you upload it to one of the cloud applications, you can access it from anywhere as long as you're connected to internet. So some people again refer to this as certain kind of high availability, but it's not technically correct. So even though your photos are always available, whatever device you use or at any point of time or anywhere, as long as you're connected to internet. So the cloud provider here, I've been saying this word quite a few times. So you guys must have heard AWS, Amazon Web Services, Google Cloud Platform, Microsoft Azure. So these are a few very big companies which have these data centers running all over the world to offer this infrastructure for end users like us. So all the photos, videos that you upload to cloud are actually always available for you, despite the channel through which you try to interact with that application. And let's say one of the servers in that particular data center gets crashed, and that's the server where your file was stored. You need not worry anything about it. These cloud providers themselves will offer that fault tolerance. So let's say you were downloading some picture from this particular rack to your phone. Now, in between, when it was about to send, the server crashed. So half of the picture got loaded, right? You need not worry about it. Hey, server crash. In fact, you need not even realize that something happened. The cloud computing provider itself configure a different channel and the download will resume for you. So here we have kind of tried to translate the high availability and fault tolerance we have discussed in the analogies. Any questions here? Otherwise, we'll be moving on with the rest of the terminologies, translating them into the relevant technical terms. Any questions? Okay. So in order to discuss the other rest of the terminology, I've chosen an enterprise case study, as I said before. So high availability, scalability, I wanted to kind of get you a feel of what exactly those applications are doing on a personal use case. So I've started this company, Ekis, in 2018. It's an imaginary company, so I can name it anyways, right? It's a very good company. It started with a 500 user base, and the title says on-premise. What it means is all the infrastructure that is needed to serve these users is set up in my office or somewhere nearby. Basically, I have control over it. I am the one who is procuring that infrastructure, that compute power. So usually we call them servers, the storage, the hard disks that we call, the networking, ensuring the physical security, renting that particular physical space, paying the electricity bill, recruiting IT admins who can set it up for me, calling for 10, quotes with various companies who would give this infrastructure. So all aspects of setting up a data center is actually maintained by me, right? Anyways, so Ekis is always viral, right? So 2018 was a good year. It started with 500 users. And in 2019, I was anticipating my user base will grow to 1,000 users, kind of, double. Now, most of the times, the predictions work. And luckily, 2019 was also a good year. All the investments I've made in procuring these servers and the hard disks and all the necessary infrastructure to serve my 1,000 users, it went really fine. Things didn't go well. Again, coming to 2020. So there was a positive vibe about the company. Everything was going good. So I thought my user base will increase to 3,000 users in 2020. So I have called for quotes. I set up all the infrastructure. I paid a lot of salaries. This whole setup costed me like tens of thousands of dollars. But 2020, everyone knows what happened. COVID-19 had impacted me, everyone, and my company as well. So the user base, instead of growing to 3,000, it didn't rise the way I expected. It only became 1,250. Maybe I should feel lucky enough that it didn't fall down. So what happened here? All the investment I've made, all the infrastructure that I've set up is actually useless. This 1,250 users can be served by like these 5 servers itself. So it's a huge waste of money. All the capital I had in my hand had already been liquidated, and they have become my assets, and I don't have a way to get money back, right? So this exactly is the problem that is driving major enterprises to start thinking in terms of cloud computing. And by this time, you should have already understood where I'm going with this particular scenario. I said I'll be discussing elasticity and scalability, correct? So the same company, now let's move it from on-premise Again, this is my imagination, so I can do anything. So instead of setting it up on premise, like maintaining everything, I used a cloud provider, maybe like a Google Cloud provider. Right? So it's the same office. Instead of having a separate data center owned by me or owned by Ekis, I'm actually deploying it in cloud. So you should remember this word deploy, because we'll be discussing the deployment models later. So what happened here? In a cloud, in 2018, I was establishing my infrastructure for 500 users. So I've set up 2 servers, right? And if you remember, I said we will also be discussing instance. So you can loosely translate that instance server here, very loosely. Again, it's just to simplify concepts, right? Now I have 2 instances here. I'm saying two sources of compute power. Now, let's say Ekis has developed a software like PUBG. It it became crazy overnight, and like Pokemon 2, right? So let's say that's the application that is being served using these instances. So once you deploy it in cloud, you don't plan for years ahead. You actually think about hours or days only. So that's why there is only a starting point. I'm not gonna discuss what is the time frame here. It can be anything. It can be the immediate second. It can be a few days. It can be a few weeks. As long as the user base increases, I can serve those users by increasing the instances here. Right? It's easily scalable. All I need to do is just do a few mouse clicks, and as long as I have the money to pay for it, again, remember, instead of setting it up on your own on-premise, which costs you tens of thousands of dollars, you are renting them temporarily, and that will definitely cost you less. And of course, when the user base increases, you have different sources of revenue to which you can definitely handle, right? Now, after a few days or after a few hours, maybe, let's say this is a particular setup around the US. So all around evening or by late night, the game that all the players were playing, then load will decrease, correct? So what will happen? During the night, maybe a few people in the night might play, a few people around the world might connect to this particular server, which even though it's physically distant from them, the players that they play here might be expert and they want to play with the experts and all, right? So it's equally elastic. If the users increase, it was able to increase the number of instances and serve the game to the increased users, and the users decrease, it was able to actually go less than what we have initially configured and even serve them. Again, it's everything is configurable here. As long you can set limits, like, okay, I need minimum of 1 instance running and a maximum of 20,000 instances running. There is no limit to it, right? Theoretically, the capacity that the cloud computing provider offers is infinite, especially in terms of compute and storage. You have multiple options, like you'll be spammed with a lot of options when you actually deep dive into it. But here, the whole point is to get through the elasticity and scalability concepts, which we frequently refer to. And disaster recovery is built in, as I said before. If it was an on-prem model, I have to worry what happens if my data center crashes? What if there is a fire accident? What if there is a security issue? What if there is a malware? Those are all my headaches in an on-prem model. But then in cloud, I need not worry about disaster recovery. So there is no translation that is needed there. So as I said, I use this keyword deploy. So there are various ways you can set up this infrastructure for the users to use. So my company, Ekis, initially I envisioned it as an on-prem model, but then I've foreseen a few problems. So I've started thinking in terms of moving it to cloud. Now, what if there is a national investigation agency, right? They want to store all the files, everything in some storage, and they want to process that information somewhere. They need some infrastructure. One option is they can have their own infrastructure on-prem. But again, you have seen the problems with on-prem. So they want to move to cloud, but they are worried about sharing the same kind of resources with the public. So usually cloud computing, when we say, we use the term called multi-tenancy. So tenant is something, who is paying rent to stay with you, right? Multi-tenancy is nothing but multiple tenants are actually paying to use the same resource. That's it. So based on the use case, you might have to deploy into cloud in different ways. So how do we explain that again to a layman? So let's use an analogy. So deployment models are categorized into 4 types. One is public cloud, one is private cloud, community cloud, and a hybrid cloud. So the analogy I'm trying to portray here is, the whole goal is to travel from point A to point B. That's the application of my, for me, right? So if I do that using a public transport, the advantage is I need not worry about anything. Everything, all the transportation system, everything is set up, all the timings, how many people can be accommodated, everything is set up. All I need to do is just use that particular ticket and travel from point A to point B. And because it is shared by masses, it will cost you really, really less. Again, I can travel from point A to point B. Instead of using a public transport, I can buy a car and do it. Only thing is, it's a bit costly, and I am the one who is supposed to maintain the car. I am the one who is supposed to fuel it. I'm the one who is supposed to drive it and ensure I'm driving it safe and all, right? So private cloud, for me personally, I feel it's more of a scaled on-prem solution. So you're not sharing it with anyone, but you have that all the scalability, elasticity to within the limits that you have budget for. So you'll provide a network, private network for your employees to connect. You're not sharing these infrastructure outside with anyone else. So you're confident that your data is secure. Having said that, it is only because of the government regulations that you'll think about private cloud. Don't worry about the security of the files you store in public cloud, because data is encrypted everywhere. In transit, during when you store, the data is encrypted. When you transfer the data is encrypted. And in fact, there is a concept called envelope encryption, which ensures the encrypted data itself is encrypted. So it's kind of a 2 layers protection, especially in Google Cloud Platform. That's the kind of security they offer. You need not worry about storing your files on a public cloud as long as the government regulations allow. Then comes the community cloud, right? You wanted the comfort of a car, but you don't have the capital to buy a car. So a group of people, what they do, they have the same interests. Hey, I don't want to, travel by public transport, but I want to move from point A to point B with the comfort of a car. That feels like, okay, I own this. It's my car, kind of, right? So what they do, they come together and they set up the infrastructure um, and maintain it together. They pay for everything together and they share the costs. So it's kind of a community cloud. And then by now you should have understood what a hybrid cloud means. So it's a mix of the comfort and the fare that we'll be paying. So private cloud and community cloud, kind of expensive, but then hybrid cloud offers the comfort of a car, but at a relatively cheaper price. So hybrid cloud is actually offering the comfort of the cloud computing world at a relatively cheaper price. So what will happen is, let's say during Black Friday or Black Friday sales, especially in the US, and during Great India festivals in India, we have this Amazon, Flipkart, all these online delivery sites. Let's say they have everything set up on-prem, right? On a regular day, they are able to serve those users. But on peculiar events like Black Fridays and Great Indian sales, they anticipate a sudden rise in the user base. So what they'll do, they'll configure their systems in a hybrid cloud methodology where the sudden increase in the user base will be served by a mix of their on-prem systems and the cloud systems. So that's how they'll be tackling it. And once the user demand reduces, the cloud resources get reduced. And as I've said, cloud resources are only charged on a pay-as-you-go model. So when we increase the usage, the price gets increased. When we decrease the usage, the price gets reduced. This is an example. Honestly, I don't think they have on-prem systems, Amazon and Flipkart, but I just wanted to get that point through. So, one of the major explorations you could do in real world is mostly in public platforms. So I just wanted to give a perspective of how big the public cloud platform is by taking a Google Cloud platform as an example here. So each point here, you could probably think of them as a data center, right? And in fact, that's a region. Within a particular region, we have a lot of zones, and each zone has a lot of data centers. So I'm not gonna, complicate that. Just think of it one data center, another data center. So the point I'm trying to explain here is everything is connected. It's a vast network. If you are user in West California and you actually want to interact with someone in, let's say, Australia, you could do that. And in fact, it's based on the network latency and the situations, it might get out via Pacific, or it can take anywhere through this. So don't worry, just understand that it's a huge infrastructure that the public cloud providers are offering, like Google Cloud Platform, AWS, Azure, and all. One funny thing is, when I started exploring cloud computing, I always wondered why exactly cloud? What that cloud signifies? Can I go out and see there is a cloud moving? Should I think of as a computing resource? Or if it rains? If it rains, will the cloud computing system work? And of course, I'm in Costa Rica, so I should worry about volcanoes. If a volcano rises and it erupts ash, will the cloud computing system work? It's all kind of crazy thoughts, right? Turns out they're referring to all this mesh of network software layers as a cloud, right? Honestly, if someone asked me to name such a system, I would have probably named it an ocean computing system, because most of it is actually connected by oceans. Unless when Elon Musk successfully implements his Starlink network, the network of satellites which are actually floating above us, that could probably be considered cloud. Anyways, I just wanted to give you an overview of the scale of a public cloud provider. Then comes the service models, right? There are various ways you can service your users, and we have so far discussed mostly at an infrastructure level. Like I've been saying, compute power, storage, network, security, all that. But then there are multiple layers that can be abstracted for the user. Again, we'll try to discuss this with an analogy. Pinto, qué rico. So this is the service models analogy. For people outside Costa Rica, gallo pinto is a staple dish here, like masala dosa, idli sambar for us in India. So my point here is, I want to eat gallo pinto today, right? There are various ways I can satisfy that requirement. One, and the most common thing first I think of, because I love cooking, is on-prem, which I'm calling it made at home. So I prepare all the ingredients and I cook. I arrange all the dining table. I clean the kitchen vessels. I use my own electricity. Everything is managed by me because I'm making it at home. Now, there is one more option, which is buy and cook, right? I can buy a few things from a vendor, get it to my house and cook it, right? So I need not worry about certain layers beneath, the stuff. So everything I need. So here I was actually growing everything too. Here I need not worry about anything. I buy everything, come here and use on top of it. I cook the dish. If I am even lazy to cook, there is one more option, right? I can order it online, maybe in Uber Eats, Glovo, Zomato, wherever. All I need to do is just order it, they'll deliver it. I just, kind of set it up on a platform like a dining table and enjoy that particular dish. So here I'm referring it to as IaaS. If you see it here, it's infrastructure as a service. And PaaS, it's a platform as a service. There is one more option too. I just can go and dine out. I need not worry about anything at all. So everything, even the platform, the dining table, plates and cutlery, everything will be served. I need not worry about cleaning it. Nothing. I just have to enjoy the service or the product that they're offering to me. I just need to eat it responsibly, right? So that's kind of a software as a service. So everything is abstracted for you. You need not worry about anything. All the blue lines here, everything is managed by vendor. You have nothing to manage. You just have to use it or eat it. So let's translate this into the relevant, again, the cloud computing world. So as I said, on-prem, I was referring it to as made at home, infrastructure as a service, platform as a service, software as a service. So on-prem, all the servers, storage, networking, the virtualization that I have to do to provide the virtual machines to my users, OS management, any middleware, everything has to be managed by me. But in infrastructure as a service, certain layers of it is abstracted for me. I need not worry about anything at all until this layer. But which OS to use and which applications I have to run, everything I have to manage and decide. So this particular offering, we call it infrastructure as a service. So what they're doing, they're offering all that infrastructure or of computing power or servers as a service. That's why it's called an infrastructure as a service. Then we have platform as a service. So platform, you in kind of the abstraction level increases for the user. So they need not worry about any OS or what the dependencies and all. You just have to develop your application on that platform as a service and deploy it. And then software as a service application. So let's say Microsoft Word Online or Google Drive, or you're not doing anything at all. You're just using that application over the internet, right? Everything is managed and done for you. Everything is abstracted for you. So I would say like Salesforce, everyone sees Salesforce as a cloud platform, but then Salesforce is known for its software as a service model. Google Cloud Platform, on the other hand, it's known for all these models. And Salesforce, to some extent, it offers platform as a service as well, where you can develop some applications there. And it doesn't really it's not known for IaaS at all. So I hope this discussion of cloud computing, what it is for a layman, the terminologies, the deployment models, the service models, I believe by now you guys have some sort of understanding. If two cloud computing guys or if two geeks discuss, hey, we have to configure this system in a high availability mode, in a fault tolerant mode, and it needs to be scalable, it needs to be elastic. I hope you guys have some sort of clarity right now. Even the deployment models, don't really worry about what is what. All you need to, there are no physical actual boundaries in the service models too. You just have to understand the implications of using a particular service model. What is managed by you and what is managed by vendor, and what is the shared responsibility that you guys have. So as long as you have that understanding, it doesn't matter if it's an IaaS, PaaS, or software as a service at all. So with this, thanks for joining us today. We really hope you guys are on cloud 9 now. I'm open for any questions.
Thank you, Akshay. Any questions? Well, I have a question actually.
Yeah.
I know many people is thinking in create probably a new project during these times, and that's probably because everything changed, right? So all business, well, maybe not all, but many business required to change their models or their strategy to sell and everything, right? So when, for example, if I'm gonna start, let's say, a new way to do my business, when or should I start thinking in maybe using a cloud provider? I mean, when is a good time to start thinking in a cloud provider?
As long as the government regulations allow you to, store the data. Again, they differ based on the region you are in. Like, for example, if you're dealing with health insurance data, you have to worry about HIPAA. And if you're processing the data in the US, you have to ensure you're using a HIPAA compliant system. And if it's in the Europe, it's again the global GDPR, right? So with that out of the way, if you're solely worried about the infrastructure, actually, I think now is a good time. Of course, any time is a good time for cloud, because you need not think way ahead. You need not predict a lot of things. You need not plan for anything. You need not recruit a lot of people before. All the capital you have in your hand, you can, instead of setting up the infrastructure, you can actually use it to develop something. And once the application is ready, you have that revenue stream that you're looking for already. And you can always scale based on the pay-as-you-go model. And one good thing is all the major public cloud providers, they offer a free trial. Again, this session is solely as a general introduction to cloud computing. Based on the, will be response for the event, we'll try to introduce a particular cloud platform, most probably Google Cloud Platform, and how to use that sandbox they offer, or how to use that free trial, and even how to navigate within Google Cloud Platform. We'll do that. But then, to answer your question, anytime is a good time to start thinking about cloud. And I've been saying cloud is awesome. It offers all these features. At the same time, you have to be aware of the costing methods. I've not discussed it here yet. I just wanted to get it around because recently NASA, apparently they have moved some of their data to cloud. And when we talk about NASA and their data, it's not small, correct? It's huge, really huge. They had their on-prem system and they had some troubles like with the scaling and the network latencies. So they have moved to Amazon Web Services. They started using S3 buckets. So I guess, again, don't worry. S3 bucket is nothing but a place where you can store anything you want. That's it. So they started storing their data in S3. It actually costed them cheaper to store it there. But then when they looked at the bill from Amazon Web Services, they were awestruck, because everything you do in cloud has a charge associated to it. They looked at the storage costs, but they didn't look at the transfer rates between the egress and ingress charges. So Usually ingress will be free, but then egress. For example, my data is stored in a cloud in, let's say, California. I'm in Costa Rica. I want to download that petabytes of information. I downloaded it. So for every GB, they cost some cents. Now scale it up in terms of the number of users NASA have, and even if a minute update is there, I'll update that, I'll download that latest data daily. So it actually became exponential. It costed them more than their on-prem model. They had these advantages of accessing it anywhere. It was scalable. The downloads were really good, but then it costed them more. So your question, in a very generic way, I would say it's awesome. You can think of moving to cloud computing anytime. But then you have to think about the costing model. You have to think about what are the consequences of hosting it in terms of regulations and in terms of the security, if there is any. One good thing is, as long as you have a credit card, if you have some idea that you want to develop, you can just sign up. You need not pay anything. You go develop your application, see if everything works, and if works, you deploy it into production, and then after a month you can start paying it. So the flexibility that the cloud computing providers offer, it's amazing, and I think that's the driving force behind majority of the startups looking to invest their time in or start their infrastructure directly in cloud, which they fancily call it the cloud native systems.
Yeah, one thing I really like from the free tiers is that, for example, I've been using Google Cloud to test a couple of things, right, and learn. But one of the things I really like is that you can start using the free tier, and they will start to send you some invoices, but they're not charging anything. They're just showing or sending, let's say, like it's not a fake invoice, but it's not actually a real charge to your credit card. But you can start checking what is the cost of your operation, for example. So you can test your product in the cloud, or you can test what they offer. So, or you can use it to learn as well, and they won't be charging you anything, at least until a year. So I think that's a really cool thing. If, for example, if people want to learn more about it.
Right. Yeah, let's plan one. Let's send a feedback, and if everyone is interested, if we have like minimum participants, we can actually have a series of sessions to show what we have done and how to navigate and be a kind of a evangelist promoting Google Cloud.
Sure, definitely. All right. Any other question?
Guys, if you have any questions, you can send a chat, or you can.
Hey, Akshay. Yes,
Yeah.
sir, yes.
Yeah, what is the best SaaS that you have worked on? Recently, I started working on Salesforce, so I really think the success behind Salesforce is, the way they serve the users. Every feature that they have tried to incorporate is actually useful. For example, Service Cloud. You think of a company and you think of the kind of support you want to provide to the users. Whatever you think is actually available there. All you need to do is just subscribe to that particular license and start using it. And of course, all these days, Microsoft OneNote or Microsoft Word or the collaboration that they are offering because of this cloud computing model, like 3 or 4 guys can edit the same document together, and whoever is editing a particular section, their name will be displayed there. It's amazing. The collaboration that I call it a cloud superpower. So all these SaaS applications are actually superpowered by this cloud computing systems. And if anyone wants to share, like Alfredo, like what he has shared about your experience with cloud, all that, then feel free to chat or feel free to raise your hand. We can unmute you. Okay. In order to pursue learning on any cloud platform, there are plenty of open resources available. So if you first things first, you choose a cloud computing platform. In majority of the cases, as it's a public cloud provider on which you'll be working. So if you choose Google Cloud Platform, just let me type it right away. So they have amazing documentation. For that matter, any cloud provider, even AWS, Azure and all. So it's organized very well. You just click getting started. Again, guys, remember that cloud computing platform, it's a platform, right? You can't be an expert of everything. So if you're interested in developing something, you can probably start looking at the associated platform as a service resources or how to set up that underlying infrastructure, all that. One thing for sure is you have to expand your wings. It's not like a traditional on-prem model where you are an expert of something and you can remain only in that particular area. You have to expand your wings and start learning new things in cloud. But then it takes some time. I hope this session will provide some direction on where to look for. So just go to the documentation resources. And if you are particularly interested in knowing more resources on Google Cloud, you can, we keep organizing these events from GDG Puravida, a lot of GDGs around you. So you can sign up for any events, we'll let you know. And if you want to know more, you can also refer to a lot of YouTube channels. And in fact, this month, Google Cloud is offering 1 free month of access to its Coursera and Plural site. They both are learning platforms. You can message me. I'll send you more details too. If it is related to Google Cloud Platform, that's where my kind of familiarity lies. There's a message from Vishal. For me, I cannot say the best one, but most of the apps I use on a daily basis, like Uber, Lyft, Uber Eats, DoorDash, which are SaaS, I like a lot. Yeah. Currently, there is a Google Cloud Learning opportunity, which I'll share with the organizer. Great, awesome. We'll probably send an email out with the details to all the users. Great, thanks, Vishal. Any more questions?
Yeah, say, can you hear me? Can
Yeah.
you hear me?
Yes, I can hear you.
Hey, Akshay, yes, sir. Yeah. So first of all, thanks for your time and effort you are putting into this. Yeah. So this is the great content. So my question is regarding the. Can you hear me? Right?
Yes, I can hear you.
Yeah. My question is regarding the term scalability you have told, right? So
Correct.
what I understand from the scalability is like capability to reduce or increase the size, right? Or something like that. So what I think is, let's say I am running a small business and I bought some Google Cloud service, right? And let's say like we now came to 2020 and suddenly I lose some of my business, right? So what contingency plan Google has in order to reduce my loss or something, right? Because the resources is already been occupied.
Well, there are various contingency plans Google Cloud is offering, but then that's more of a company policy that they have publicized. So I'm not, as far as I know, they are offering deferred payments. So you can pay the bill like maybe 6 months or 1 year later. At the same time, when you say the resources are already occupied, that doesn't really apply to the cloud computing world, right? Because if you're not using that resource, you can just release it. You won't be billed for it. That's the whole point of
Right,
the
I understand.
scalability and elasticity, right?
I may not be asking the correct question. I totally understand. Yeah, just trying to uh, make something of the word scalability here. Yeah. So if I don't know if I ask the correct question.
No, I mean, you can still ask. There is no wrong question or right question. Um, questions will be right. Answers have to be tuned. That's what I feel. So if I didn't answer your question, you can still ask it again. So scalability and elasticity, they go hand in hand, right? Because elastic, it's not just the reduction, but you can expand it too. Now, if your question is about right now, I'm not using the resources that I used like earlier, then what do I do with them, right? There are certain scenarios where you are supposed to have those resources running forever. That depends on the kind of architecture that you have built into your system, right? For example, if you have a proprietary license that you want to transfer from your on-prem to cloud, you want to use an infrastructure as a service, maybe a compute engine, and install that license and ensure that it is running permanently. Now, despite the fact that because of COVID-19, the license or the application is not actually being used, you can't stop it. So in those cases, this is not an official statement from Google Cloud, but I've read it somewhere that they're offering a method of deferred payments. So regularly you used to pay it monthly, but then because of this situation, you can pay it like 6 months or 1 year down the line. And if that's not the case, where you don't have a system where it has to run permanently, then it's amazing, right? You need not worry about running it at all, because if you don't have the user base, you can just simply release the resource that you're using and you won't be billed at all. Does that answer your question? Yes, sir?
Right. It does.
Great.
Thanks, sir.
Any other question, guys?
Akshay, regarding the technologies embedded in the cloud computing, will you mention some of them?
Like, I didn't get that question.
Yeah, what I mean, like, how does it work? Like, if you say cloud computing, right? So, like, there will be some, let's say, some technologies or what I can say, languages is used. Like, since you are data engineer, right? So, like, how does it work? What do you learn? Like, you are Google certified data engineer, right? So, like that. What languages do you use or something? What are the tools you use? Something.
Okay, so as a data engineer, you're required to shortlist the sources that you probably are intending to use, come up with a plan on how do you aggregate them or process them or clean them first, maybe a staging layer. Then there is a ETL processing pipeline that you have to build. There are multiple options in Google Cloud. Once you transform the data using the ETL pipeline that you build, you can store it in the various kinds of databases you have. It could be BigQuery, that's a serverless data warehousing solution offered. It could be Bigtable. It could be, if you're having a license of MS, the SQL Server, you can transfer it to Google Cloud, and it can be scalable, but within certain limits. So depends on the application. Yes, sir. So based on the scenario, you can fine tune it. In terms of languages, so far I've seen, especially in the ETL world, that's where ETL and the data warehousing world where I work usually, I've seen Java and Python being used predominantly. And at times, while getting the data into the Google Cloud, you might have to use some queuing systems too. So we have Cloud PubSub. So a little bit of messaging systems familiarity will also help. What else? So basically, as a data engineer, you have to think of ingesting the data and till visualizing it. So the whole stack is offered by Google Cloud Platform. It's up to you based on the kind of architecture you're envisioning to decide how do you use that particular technologies to tool stack to use. So Google has like very good integrations with Tableau, very good integrations with Looker, and Google itself offers Google Data Studio. It's free of cost, and even for BigQuery, ingesting doesn't cost. You can do some real-time analytics. It's on a case-to-case basis based on the kind of application you're trying to build and the kind of architecture you're referring to. You have plenty of options.
Thanks, Akshay. That was very helpful. Yeah.
Thank you. Any other question, guys?
Okay, seems we don't have any more questions for the moment. If you guys have more questions in the future, you can contact us, of course. If you want to also share your knowledge or give a talk, also drop us a message and we can talk about it. Also, we'll be hosting more events. We don't have the next date, but we probably will be hosting more events about cloud, about web technologies, also Firebase and other stuff. So, well, thank you very much, Akshay, for the presentation. And
yeah,
see you next time.
Sure, Alfredo. And everyone, will be sending out a survey link, how you felt about the event. So it would be great if you could take some time and fill it for us. We'll be following up on what topics you'll be interested to know more so that we can organize more sessions. And we'll probably try to accommodate a few sessions during, IST too. So watch out watch out your mailbox. We'll be sending a survey soon. Thanks, everyone.
Thank you so much.
Bye. Have a good weekend.